Welcome to this tutorial on how to record statistics in OMNeT++ using built-in data collection functions. In this video, we will build upon the project from previous tutorial where two nodes send message to each other with a delay. We will now focus on recording the delay and the number of messages received during the simulation. If you are new to OMNeT++, we recommend watching the first video in our tutorial playlist. If not, feel free to watch this as a standalone video. There are 5 steps required to record data from the simulation. First, define the statistic keyword in the .ned file of the network. Second, define the @signal keyword in the .ned file of the module. Third, define sim_signal_t type in the .h file of the module. Number 4, register the signal in the initialize using register signal function in the .cc file. Fifth, generate statistic values using emit function in the .cc file. The first step in recording statistics in OMNeT++ is to define the @statistic keyword in the .ned file of the network. In this case, computer network.ned. To do this, add a new section titled parameters and type @statistic, followed by a square bracket with the name of the statistic of your choice, and close the bracket. Next, specify the source of the signal. For now, let's use another variable which can be anything as per your choice. After that, add a semicolon and then record. The recording mode defines how you want to store the signal, such as sum, vector, minimum or maximum value. The choice of recording mode will depend on the analysis you need to perform. For this project, we will record the count value of the variable, which is the total number of messages received by both the nodes, and a vector value for the delay with the variable name total delay. In the next step, we will define the signal keyword in the .ned file of the module. To do this, open the computer.ned file and add the @signal keyword under the parameters section. Mention the variable you named in the step 1 followed by its data type. In this case, messages received is of type int and delay is of type double. In step 3, we will define sim_signal_t type variable in the .h file of the module. This is done because signals are identified by names, but internally, numeric signal IDs are used for efficiency. To do this, open computer.h file and under the private access specifier, add sim_signal_t followed by a new signal name. For easy understanding, we will use the name of the signal declared in step 2 and adding signal to the end. For example, message received signal and delay signal. These names can be anything of your choice, not necessary to be based on the names of the signals declared earlier. In the fourth step, we will register the signal in the .cc file. The register signal method takes the signal name as a parameter and returns the corresponding sim_signal_t value. This is where we connect the signal declared in the step 2 to the sim_signal_t in the step 3. To do this, in the initialize function of the computer.cc file, add the following line. Messages received signal is equal to register signal bracket open messages received bracket close. Similarly, do this for the total delay signal variable. The final step would be to emit the parameters of your choice, which is done by using the emit function from a module or channel. Emit function takes a signal ID, which is sim_signal_t, and a value that gets recorded. So for this project, in the handle message function, which is a function that is called every time the computer receives a message, we include the emit function. For this, we write emit message received signal, comma, message received. Similarly, for delay signal, emit delay signal, comma, delay. But here, you might have noticed that the two variables we are recording have not been used anywhere. In order to feed them with value, first we'll declare the two variables in the .h file under the private access. Then, in the .cc file under the handle message function, we'll increment the number of messages received by 1 every time a message is received. We'll also declare a separate variable for the delay and replace the uniform function in the scheduled at function with this new variable. This way, the simulation will keep track of the two important variables that we will be analyzing after the simulation. To run the simulation, go to the Project Explorer, right-click on the project and select Run as OMNeT++ Simulation. You can choose to run the simulation in normal or express mode. To view the results of the parameters, go to the Results folder in the Project Explorer and double-click on the SCA file. You will get a prompt about the .anf file, which is the analysis file that enables you to read scalar and vector files. Under the Scalar tab, you will see the total number of messages generated by both the computers. And under the Vector tab, you will see the mean delay. To visualize the delay over time, right-click on the vector variable and select Plot. This will generate a line chart showing the delay over the simulation period. To give an overview, in this video, we saw how we can record signal and statistics in OMNeT++ project. We hope this video was clear and easy to understand. If you have any questions or feedback, please leave a comment below.